Hello YouTube, this is Ajit from Studio Tree. We're going to take a look at the various materials used in the test character provided with the MB Lab study project on GitHub today. So we'll start with the most basic material, the bottommost slot, which is used for the skirt. Using another instance of this material even for the shirt as well. It's a really basic material. I've added a few parameters here. You should try to parameterize your materials so you can reuse them, and we parameterize base color and pixel depth offset. World position offset allows you to move the vertices along the normals. That is the way I've implemented it in this material. This allows you to make the mesh look like it's either enlarged or shrunk. So the next material is the hair material, and I got this from the Unreal Engine forum. Made a very small modification to it to add in the opacity mask. The opacity mask was required for this character because the hair strands had to be seen. Other than this material offers a lot of options. You can change the highlight color, there's also a glossy factor to it, the glitter, and material can be tinted, plus you have the option of adding a gradient, that is having a start color at the top of the texture and another color at the bottom. That allows you to make like some really cool effects on the hair, as you can even see for this female character. Now I placed the hair material in the common folder, and all materials which are being shared amongst all characters are placed in a common folder. You should try doing something like this and create instances from this common folder and place them amongst the characters which need those particular instances. So the common materials will be separate, but the instances or the child blueprints can be placed along with the actors or along with the assets which require them. Oh, this is the place where I made the change in the hair material. I've added the mask here. So the next material we have is that we're going to look at is the eye refractor material. So the eye refractor material takes care of the tear line. So over the eyeball there is this small or very tiny layer of liquid coating in, and it gives a shine to the eye itself. And we just made a basic translucent material with the Fresnel node to provide small amount of refraction and also add that glossy effect to the eye. So the next material is the material used for the eyeball. If you study the character, by the way, the tear line has a separate mesh and the eyeball again has a separate mesh. The eyeball has a U node which allows you to change the color of the iris, and as you increase the value from 0 to 1, the colors change using the U node. There are also other options. There are quite a lot of parameters, and you can change the roughness, also the size of the eye by changing the pixel depth offset or vertex offset. You can get a cartoony like effect. The cornea again is a separate material because it is separated, it is a separate mesh, and that was required because the morph target allows you to increase the size of the cornea or decrease the size of the cornea, and for that it's placed on a separate material slot. I have a feeling that you could also join them up and save on your material slots in the end. So yeah, you can even make black eyes also, changing the brightness. There are two options of Fresnel, and the Fresnel affects the black around the edges of the eye, that is the parts going into the skin. And you can also increase the brightness of the iris and change the way the glossiness is, that is the highlight. And there are a lot of options. You can try checking them out. You can check out the two types of Fresnel. As I said, Fresnel is just selects the pixels which are looking away from the camera vector, and the second Fresnel option allows you to change the input vector, so you can affect the direction of the reference point with respect to how the pixels which are looking away is calculated. So you can see the light direction. You can change that on that node. Right now I've just passed in the camera vector to it. You can see how I use the blend corrected normals to get that effect over the eyeball. That is, I don't know what to exactly call it, but you can see the normals look a little wavy. It looks like waves. So the next material is the Eyelashes material, and the Eyelashes don't use a mask material, instead they use a translucent material. I did not use a mask because the texture looks really jagged if you use a mask. You can see it looks a lot more smooth as a translucent material. You could probably try making some variations of the hair material by using translucency instead of masking. And yeah, most of the materials do have a parameter for color that you can change the color of the eyelashes or the skin or the hair or the clothes. It's good to add parameters, and that allows you to have more variations and share materials amongst many meshes. You could also try implementing certain parts of a material as a material function, so that you could reuse those material functions in new materials. So the next part we're going to look at is the basic skin material, that is the simple skin, and we use this for the gums and the teeth. It has a few options. If you increase the specular and decrease the roughness, you can make it look like it's wet, and you could even add another layer of complexity to this by adding in a mask and changing the effect over the gums and changing the effect over the teeth. You'll have to create a mask texture on your own. And if you want to find out how to mask a texture with another texture, the next material which I'm going to show you, that has a couple of examples for masking. So let's take a look at that. So this is the skin material, and the skin material has a lot of options. I think you should spend a little time studying this. You can take a look at the process of masking, and even show you the texture mask. So what we do with the masking is we assign different regions of the UV space a particular color, so that we can select that part of the texture, and we can change the roughness, specular, metallic attributes of that region, so that we can have different roughness, normals, specular and metallic properties for different part of the UV space. So we can see here there is the lips are being highlighted, that is masked with the red color, and what we've done is we used a separate normal texture for the lips, which gives it a sort of striations. The normals look like they are having striations and gives the texture of lips. And we've put a basic noise texture for the skin, and that makes it look like there are pores over the skin. You can check out how I've done the masking by studying the material. Now the ambient occlusion affects how dark the material looks in the shade. So if you make it 0, it looks really dark, and you make it 1, it looks brighter. You can also add an ambient occlusion texture if you want to export them. You could probably export it in Blender. see there are a lot of options available. Using the masking technique, we have masked the toenails, the fingernails, the lips, so that we can change the color also over the lips and the toenails and the fingernails. And I think you can probably encode up to 6 or maybe even 7 regions into one texture by using one primary color for each region that you want to mask. So you can use red, green, blue, and then the secondary colors. You can use cyan, magenta, and yellow. And if you really want to cram even more stuff, you can probably even use white. So when you have the three colors overlapping, you can use a specific math formula to try and select only those parts of the UV space, and you can probably tint that particular region or change the specular or the metallic properties. I'll be showing you how affecting the masked regions changes just those regions of the material and does not affect the other parts of the material. So it looks like a big spaghetti mess, but you can notice that it's if you take the time to look at it, just disconnect all the other nodes which you don't want to look at and just look at one particular mask, see how it is set up and see how it carries on to the next mask. You can understand the procedure is pretty simple. Just keep passing the input from one mask to the next mask and then finally take it to the base color, or we multiply it with the specular or with the roughness or metallic or even with the normals, and you can just affect particular regions. And you can see that the base texture also is there, and we multiply the base texture with the regions of the mask. And you can see we have a lot of static switches, and you can disable certain masks by using the static switches. So this texture mask, I guess, has only 4 colors encoded. It is the red, green, blue, and cyan. So green and blue gives cyan. That's what the use GB is: use green, blue, use cyan. And we have a static switch for this, for enabling texture masking or disabling texture masking. Static switches are really great because it reduces the material complexity. That is, if you don't need features, you disable them and it reduces the number of instructions. So if there are certain parts in your material which you think may not be used in certain instances, you can place a static switch ahead of that particular region, so that instead of disabling it by using 0, which still contributes to the number of instructions, disabling the static switch will disable the whole section altogether, and in that material instance will reduce the number of instructions. Here you can see how I'm changing the color of the lips alone by using the mask. Similarly, you can even change the color of the other regions, like the nails which I masked. So the texture masks themselves were created in Blender. You can use the paint tool in Blender to paint certain regions of our texture. You can always get into UV mode, look at the UVs, and you can start painting just the selected faces. So you can select the faces and fill them up, and then that's how we generated the masks for this character. Oh yeah, the final mask is the underwear. Oops. Oh yeah, and by again reducing the roughness a bit and increasing the specular, you can make the character look slightly wet. And let's take a look at how that looks. Oh yeah, you can even change the metallic properties. So metallic multiplier multiplies over the existing metallic. take a look at why I did that, because we wanted to be able to multiply even the metallic amounts in the masks separately, and once you take a look at the breakdown of the material, you'll understand why I did that. So you can see each mask has a multiplier of its own. Mask 3, mask 4, mask 5. So mask 1 is red, mask 2 is green, mask 3 is blue, and mask 4 is cyan. So here we're changing mask 3's properties like the roughness and the specular. You can change the way the nails look. We'll also take a look at how the specific, that is the regions again which have been masked, we apply another normal texture over it to give it a look of skin pores, and here you can see the lips also being done. Is the scaling the normal texture which is placed over the skin texture. Here you can see now it becomes very apparent. You can really see how clear the noise texture is when you make the scale really small. So we scale it up and it starts to look like pores. It's just the basic noise texture. So the more masks you have, you could probably create a mask for the elbows and the knees as well, and you can add a different noise material there which makes it look identical to how elbows or knees look. So here you can see how changing the normal map intensity on the lips makes you see how the normal texture looks. So we keep it at a very low value, so that looks kind of good. This is a similar concept we used even for the eyes. You can see that we put another normal map there. We put a wavy sort of normal map, and here we put something which looks like striations, fibers. So this sort of covers all the materials that we have here, and why don't you try playing around with them and start creating your own MB Lab characters, import them in the project, use the existing materials and see what you can do with them. And if you could include your videos in the comments, it'd be great, because we'd love to take a look at them to see what you made. And if you find this useful, please do like and subscribe.